Hi students, you might have heard your teacher saying that the voltage across a resistor is proportional to its resistance, and you wonder what it actually means. I'm going to explain to you what it means and also give you some examples to work on. Alright, so we say in a series circuit, the voltage is shared between resistors. The bigger the resistance, the bigger the share of its voltage it gets. Conversely, the smaller the resistance, the smaller the share of the voltage it gets. Okay, it says the voltage across a resistor is proportional to its resistance. Now, what does it all mean? Okay, so let's say we have a resistor. Okay, we have a resistor and we have a voltage. We say there is a voltage drop of 10 volts, and it drops to 0 volts. Okay, 10 volts drop to 0 volts, and there's a current through this resistor. So let's say that this resistor is 100 ohms. Okay, let's say this resistor is 100 ohms. Okay, and let's draw it pictorially. That is the resistance. 100 ohm, this 10 volts will fall across this 100 ohms. Now, if I divide this resistor into two, okay, means here is 50 ohms. Okay, 50 ohms, and this is 50 ohms. Now, what it means is that this 10 volts will be divided equally between these two parts of the resistance. So you can guess, now you can guess, this will be 5 volts, and this will be 5 volts. Okay, so there is a drop, a drop across here. 5 volts drop, 5 volts, 5 volts drop. Now what happens if instead of 50 50 ohms, let's say I divide it, okay, and I say I divide it into 4 parts. I divide it into 4 parts. So then here will be 25 ohms, okay, 25 ohms, 25 ohms, 25 ohms, 25 ohms. Okay, what will be the drop across each of this ohmage? And this will say that this drop is, of course, 2.5 volts, 2.5 volts, 2.5 volts, 2.5 volts. Right. Now let's say I drop across my resistor. It is okay 20 ohms. Okay, 20 ohms, 20 ohms, 20 ohms, 20 ohms, 20 ohms. What will be the voltage drop across each of these 20 ohms? And now you guess it. Right? This is 1, 2, 3, 4, 5. So you divide this into 5 parts. So sorry, you divide this 10 volts into 5 parts, and each part is 2 volts. So this is 2 volts, 2 volts, 2 volts, 2 volts, 2 volts. Let's try again. Now let's say I divide my resistor into one part and one part and 4 parts. Okay, so this is 10 ohm. Oh, sorry, let's say this is 10 ohm and this is 90 ohms. Okay, one part and 9 parts. 10 ohm and this is 90 ohms. What would be the voltage drop across the 10 ohms and what would be the voltage drop across the 90 ohms? Okay, across the 10 ohms it will be 1 volt, and across the 90 ohms it will be 9 volts. Again, you can see that this is divided equally into 1 part and 9 parts according to the division of the resistor. Okay, so that is what essentially it means, that the voltage across a resistor is proportional to its resistance. Now what we do is we say to calculate the voltage drop across one resistor in a series circuit, use this particular formula. V part is equals to V total times R part on R total. Now how do we get this particular formula? Okay, how do we get this particular formula? Let me show you. We say that the V part, okay, V part on the V total, okay, is equals to the R part on the R total. Now you can see that this is just saying is proportional. Okay, this is proportional. Or we can say that or put it in the ratio form. We can say the R part to the R total, okay, has the same ratio as the V part to the V ratio, V total. Okay, V part to the V total. Now this two form, this one form and two form, and the third form, they are all expressing the same idea, So if you take the first form, V part, and you do the algebra you multiply both sides by V total, or as some of us will say, we bring this V total to the other side, and you'll get this formula. So V part is equals to V total multiplied by R part on R total. Okay, so this is the various parts. V part is the voltage across the resistor you are looking at. V total is the total voltage from the power supply. R part is the resistance of that one resistor. R total is the total resistance of the whole circuit. So now let's try one example. Let's try one example. Now what is the voltage across the 4 ohm resistor? Okay, let's call this resistor 2. Let's call this resistor 1. Okay, what is V2? Okay, what is V2? So we're going to use the formula, and we say V2, okay, which is the part of the voltage across the R2, is equals to the input voltage, okay, which is 12 volts multiplied by R2 divided by the total voltage, total resistance, R1 plus R2. Let's call it R total. Okay, so you can see that this is 12 times R2, 4, and R total, this is series, so not 5 plus 4, that is 9. And we are going to, so that will tell you this is 5.3 volts. Now what happens if I want to find instead, I want to find V1. Now I want to find V1 instead. Okay, I want to find V1. So if I want to find V1, we use the same principle. We say V1 is equals to 12 volts. Okay, that is the 12 volts multiplied by, now the voltage across this R1 resistor. Okay, this is what we are. The V1 is the voltage across the R1 resistor. So we multiply by R1 divided by R total. And that is equals to 12 times R1, 5, divided by the total is 9. So this is equals to 6.7 volts. Now you can see that the voltage V1 and V2, if we add V1 and V2 together, V1 plus V2, that should give us 12 volts. Okay? So which is the 12 volts here. Alright, so what we have here is that the voltage is divided proportionally to the resistance. Okay, let's try another one final example. Now we want to find what is the voltage across R2. Okay, what is the voltage across R2? So how we find the voltage across R2? We say if I take the part resistance, which is 3 ohms R2, and divided by the total resistance of R1, R2, and R3, then multiplied by the voltage input, I'm going to get V2. Okay, because this V2, because the voltage is proportionally distributed across the resistance. So let's go. V2 is equals to V in multiplied by, okay, the resistance in concern, R2, divided by the total resistance. Okay, so that equals to 24, which is the V in, multiplied by R2, which is the 3 ohms, divided by R total. Now R total, these are in series, so 2 plus 3, 5, 5 plus 4, 9. Okay, so with that, we get 8 volts. So the resistance across R2 is 8 volts. Okay, I hope this has been useful to help you to understand how you calculate the voltage across the resistance and what the teachers mean when they say that the resistance is proportional to the voltage across it.